Hello everyone. I hope you're doing well and welcome to this learning session. Today we're going to explore the fundamental building blocks of our digital world, servers and IT infrastructure. Imagine IT infrastructure as the entire support system, all the hardware, software, and networks that allows an organization to function, much like a building's plumbing and electrical systems. At its heart are servers, which are specialized computers providing services. They are truly the foundation of modern technology and power everything from simple websites to complex organizational computing. Understanding this is key to truly grasping how our connected world operates. Let me show you what a server really is. Imagine it as a super reliable, specialized computer, unlike your regular PC. Its whole job is to run 24/7, tirelessly providing data, services, and resources to countless other computers over a network. It's built for serious reliability and performance, forming the backbone of almost every digital service we depend on daily, from streaming your favorite shows to accessing your online banking. It's constantly supporting applications and storing all that critical data we use. Time to understand the big difference between a server and a desktop. Think of a server as a specialized workhorse, built for incredible reliability and constant uptime. It's packed with high-end hardware, like redundant power supplies and error-correcting memory, so it never quits. Its operating system is totally optimized for handling tons of network services and managing many users simultaneously. Desktops, on the other hand, are designed for one person's personal productivity with consumer-grade parts. Servers truly excel at supporting hundreds or even thousands of concurrent connections without breaking a sweat. A scale desktops simply can't manage. Here's an interesting topic: why organizations really need servers. Essentially, they're the powerful engines running a company's digital life. Servers offer centralized management, making data sharing easier and security unified, like having one reliable librarian for all your books. They also support critical business functions, powering essential operations from email to websites and specialized applications. Critically, they provide reliability and scalability, ensuring systems can handle growing workloads and user demands without falling apart. It's all about keeping vital information accessible and operations running smoothly, because downtime simply isn't an option. Here's an interesting topic: modern IT infrastructure, which is essentially the interconnected physical and virtual components that make all our digital interactions possible. Imagine it as the core foundation for an organization's computing and communication. You've got the tangible hardware, like physical servers and storage devices, acting as the brains and memory. Then software, including operating systems, controls and optimizes these resources. Crucially, networks, be they LANs or WANs, ensure seamless communication across locations. Often, all this essential gear is housed in centralized data centers, which provide those critical controlled environments. Let me show you how businesses manage their tech infrastructure. Think of it like owning a car versus using a ride-sharing service. On-premises is like having your own car. You have complete control over hardware and data, but also all the upfront costs and maintenance. Cloud, however, is like that ride-share. You get scalable services on demand, paying only for what you use, without worrying about physical servers yourself. Hybrid infrastructure then intelligently combines these, offering a balance of control and scalability. It's all about picking the right setup, whether it's your own servers or resources hosted by providers, to best meet specific business needs. Let me introduce you to the specialized world of servers, the backbone of our digital lives. Think of them as dedicated assistants. File servers centralize your documents for sharing, much like a shared drive. Web servers deliver websites right to your screen, while database servers meticulously manage all the structured information behind applications. The actual business software often runs on application servers. And to be truly efficient, virtual servers allow many independent software environments to run on just one physical machine, maximizing resources and reducing hardware costs. Each plays a distinct and vital role. Let's explore the concept of IT infrastructure management, where specialized professionals collaborate to keep our technology humming. The system administrator maintains servers, ensuring optimal uptime and handling updates. Picture the network administrator as the traffic controller, managing connectivity and optimizing communication flow. Meanwhile, the security administrator is the vigilant protector, defending against cyber threats using tools like firewalls and encryption. When a security threat strikes, this team works seamlessly. The security admin identifies it, the sysadmin patches, and the network admin isolates compromised areas. This combined effort prevents downtime and protects sensitive data. Let's look at why server and infrastructure management is non-negotiable. First, proactive monitoring is key. It catches issues early, preventing costly outages and data loss. Then, solid security and backups are your digital safety net, ensuring business continuity against threats like ransomware and system failures. Finally, scalability planning means your infrastructure supports growth without performance degradation. Skipping these steps risks severe financial penalties and lost customer trust. Let me help you understand why your IT infrastructure is truly the foundation of your business success. Think of it as the organizational backbone. Robust servers and the entire IT setup enable every digital operation you run, from emails to complex applications. By grasping different infrastructure types like on-premises or cloud, you can make informed decisions. This leads to a future-ready strategy, ensuring you stay agile and competitive. It's more than just technology. It's absolutely critical for everything you do. That concludes our session for today. Thank you for your focus, and I hope this was beneficial for you. Good day, everyone. I'm glad you're here. Today we'll be examining server infrastructure, which is truly the backbone of IT. Think of it like the foundational skeleton for every digital service you use, from your favorite apps to websites and cloud storage. These are the powerful, interconnected systems that store, process, and deliver all the data that keeps our digital world running smoothly. Without this essential infrastructure working tirelessly behind the scenes, none of the amazing digital experiences we rely on daily would truly power today's digital world. It's where everything begins. Now let's dive into server infrastructure. Essentially, it's the complete, integrated ecosystem of hardware, software, and networking that silently powers our digital world. Think of it as the tireless, behind-the-scenes workhorse delivering all the critical computing resources and storage capacity that enable continuous operation. These systems are constantly responding to client requests, whether that's hosting your favorite applications, managing crucial data, or simply powering the websites we visit every single day. It's truly the bedrock for almost everything we do online. Now let's dive into the core components that make a server tick. First up, the hardware foundation is the physical backbone. CPUs, memory, and storage, providing that raw computational power. Sitting on top, the operating system like Linux or Windows Server acts as the skilled manager, efficiently handling complex workloads and allocating resources. But here's a clever trick. The virtualization layer lets us run multiple virtual servers on just one physical machine, dramatically boosting resource efficiency. And finally, those networking interfaces, think routers and switches, are the vital connections, linking systems and users together seamlessly. Let's talk about physical versus virtual infrastructure. Think of physical as owning your own dedicated servers and tangible hardware. You get unmatched stability and direct control. It's like having your own house. But with virtual infrastructure, software-based servers operate on shared physical hosts. This is like renting an apartment in a big building, maximizing resource utilization. It offers incredible operational flexibility and dramatically reduces capital costs. You can deploy new systems in minutes instead of weeks, truly forming the foundation of modern cloud environments and making complex setups far simpler and more affordable. Let's explore the concept of infrastructure differences between a small business and an enterprise. For a small business, you often see a limited hardware footprint, perhaps just a few servers, allowing for simplified management and cost-effective solutions focused on essential services. It's usually manageable by a small IT team. Contrast that with an enterprise. They operate with massive, modular data centers housing thousands of servers, requiring complex orchestration across multiple regions. This setup inherently includes built-in redundancy and high availability for mission-critical reliability, supporting global operations. It's a fundamental shift in scale and complexity. Let me guide you through the difference between centralized and distributed systems. Imagine a library. A centralized system is like having all the books in one building. It's easy to manage, but if that building burns down, all is lost, a single point of failure. Now, a distributed system is like having branches of that library strategically spread across multiple towns. If one branch has an issue, the others still function, dramatically improving resilience. This also means you can get your books faster, no matter where you are, reducing latency. This is essential for global reach and making things incredibly robust. What we're looking at here is how enterprise architecture, or EA, helps organizations connect all their moving parts. It's essentially about achieving strategic alignment, making sure all the IT infrastructure directly supports the big business goals and strategic initiatives. We're talking about a comprehensive framework design that guides the planning and implementation of IT systems for maximum agility and efficiency. And crucially, it involves holistic integration, weaving together business processes, information flow, technology, and even governance. It's about seeing the entire picture, not just individual pieces. Let's consider how enterprise architecture truly makes a difference. It's about more than just technology, it's strategic. We begin with legacy integration, which seamlessly combines traditional systems you already have with modern cloud solutions, effectively preserving investments while enabling innovation. This robust foundation then accelerates deployment of cutting-edge technologies like AI and automation. Ultimately, this leads to true business transformation, where we see measurable outcomes through optimized operations and enhanced customer experiences, much like a global retailer integrating all their systems for millions of daily transactions. What we're looking at here is why having a top-notch server infrastructure isn't just a nice-to-have, but an absolute necessity. Think of it like the foundation of a house. If it's weak, you risk costly downtime, security breaches, and performance bottlenecks, which can truly cripple operations. But when it's optimized, it actually supports sustainable growth and continuous innovation, allowing your business to scale reliably. This isn't just about avoiding problems. It's about gaining a huge competitive advantage by delivering superior customer satisfaction in our digital-first world. Let's talk about building a future-ready server infrastructure. First, you need to thoroughly evaluate your business requirements, like scale and resilience. This helps you embrace modern models such as virtualization for enhanced flexibility and cost efficiency. It's crucial to align strategically, connecting your infrastructure choices with your enterprise architecture for long-term advantage. And never forget to monitor continuously. Robust tools are key to maintaining peak performance and security. Remember, the infrastructure you build today truly shapes the innovation you'll achieve tomorrow. Thank you for joining me today. I hope this session was helpful and informative for your learning journey. Hello learners! It's wonderful to see you here. We're going to discover just how crucial server hardware is, truly the backbone of IT. Imagine all your favorite apps and websites. They don't just magically appear. They run on powerful computers called servers. Understanding this hardware is absolutely essential because it's what builds the robust, reliable infrastructure that tirelessly powers our entire digital world. Think of it as the strong foundation of a skyscraper. Without it, nothing else stands. It's truly fascinating how these physical components enable our virtual lives. What we're looking at here is the diverse world of server form factors. Think of a tower server like a beefed-up desktop PC, a standalone unit perfect for a small office or home lab because it's easy to maintain. Then you have rack servers, which are the workhorse of modern data centers, designed to be stacked neatly in racks, maximizing space efficiency. Finally, blade servers are like super-condensed computing power, ultra-dense modular servers that slide into a shared chassis. They're brilliant for high-density virtualization, really packing a punch in a compact space by sharing resources. Let me walk you through how modern servers achieve incredible power. Imagine a single CPU, like an Intel Xeon or AMD EPYC. Isn't just one brain, but dozens of brains. Those are its cores, all working together for massive parallel processing capabilities. Now picture a motherboard supporting not just one, but perhaps 2, 4, or even 8 of these multi-core CPUs simultaneously. This multi-socket design literally multiplies processing power, enabling a server to handle hundreds of virtual machines or complex data analytics workloads that would easily overwhelm consumer-grade hardware. Time to understand ECC memory, which acts as a diligent, silent guardian for your computer's most critical information. Unlike the standard RAM in our everyday PCs, ECC automatically detects and corrects those tiny, sneaky single-bit memory errors in real time. Think of it like having a proofreader constantly scanning for typos in a crucial document, catching and fixing them before anyone even notices. This is absolutely critical for servers and businesses, preventing silent data corruption or disastrous system crashes that could compromise vital databases and critical applications, ensuring robust 24/7 uptime and reliability. Let's break down computer storage. moving from the traditional to the incredibly fast. HDDs, or hard disk drives, are like old record players with mechanical read/write heads on spinning disks. They offer huge capacity but have slower access speeds, around 100 to 200 megabytes per second. Then came SSDs, solid-state drives with no moving parts, using NAND flash memory. These are significantly faster and more reliable, but for truly blazing speeds and ultra-low latency, NVMe is the next generation. Using a PCIe interface, it's like a dedicated highway for data, delivering up to 7,000 plus MB/s for performance-critical applications. Let's consider how RAID cleverly balances speed, capacity, and redundancy across multiple drives. Imagine RAID 0 as splitting data for maximum speed and capacity, but with no safety net. If one drive fails, all is lost. Then there's RAID 1, which mirrors everything for complete redundancy. You lose half your capacity, but survive single drive failures. For a more efficient approach, RAID 5 and 6 use distributed parity blocks, allowing recovery while tolerating 1 or 2 drive failures respectively. Finally, RAID 10 gives you high performance and fault tolerance by combining mirroring and striping, popular for demanding applications. Let's break down what network interface cards, or NICs, really do. Think of them as your server's network gateway, the crucial component that physically connects your server to the network. They come in super varied speeds, from a basic 1 GB up to a blazing 400 GB in modern data centers, allowing for massive data flow. A cool trick with multi-port NICs is link aggregation, which combines connections for higher throughput and offers automatic failover redundancy if one link drops. Plus, advanced NICs even do smart offloading, handling tasks like encryption directly on the card, freeing up the server's CPU for applications. Let's get into keeping vital systems online, even when things go wrong. Servers often use dual or multiple power supplies in an N+1 configuration. Think of it like having a backup engine that instantly kicks in if the main one stalls. Zero downtime. Even better, those failed power supplies are hot swappable, meaning you can replace them without ever shutting down the server, a true game changer for maintenance. Then there's layered protection. UPS systems offer quick battery backup for brief interruptions, with robust backup generators ready for extended outages. It's total peace of mind. What we're looking at here is the fundamental way servers keep their cool, which is absolutely crucial for their operation. Imagine your server rack acting like a giant lung. Cool air enters the front, passes over components like CPUs and GPUs, and then hot air exhausts at the rear. This efficient front-to-back airflow is standard in rack servers. We rely on high-speed redundant fans to manage the heat, and for ultra-dense configurations, advanced setups even use liquid cooling. Why does this matter so much? Because proper cooling prevents thermal throttling, extends hardware lifespan, and maintains stable performance under load, keeping everything running smoothly. Let's explore the concept of why server hardware fundamentals are essential. Mastering these basics, from understanding form factors to ECC memory and RAID, directly impacts your IT success. It helps you optimize performance, ensure reliability through data integrity, and ultimately enable growth for critical applications, ensuring flexible expansion. Building on this solid hardware foundation empowers you to support today's demanding requirements and confidently prepare for tomorrow. Thank you for your engagement today. I hope this information serves you well, and thank you for participating. Hi friends, I'm delighted to have you with me. Let's begin our journey into understanding modern storage architectures. It's truly fascinating. Think of it like building the perfect foundation for all our digital lives, from your favorite photos to massive business databases. We'll dive into the fundamentals of how data is stored, retrieved, and kept safe and accessible in today's fast-paced world. I'll share why knowing these structures is essential for everyone, ensuring your information is always there when you need it, fast and secure. Let's consider the 3 fundamental ways we manage data storage, often called the pillars of storage architecture. First, there's direct attached storage, DAS, which is essentially storage like a hard drive directly connected to one server, offering local block-level access. Think of it as your computer's internal drive. Then we have network attached storage, NAS, which is file-level storage accessible over a network by multiple clients simultaneously, perfect for sharing documents among a team. Finally, for more demanding needs, storage area networks, SANs, provide high-speed, dedicated networks for block-level storage to mini servers, like a powerful, shared storage infrastructure for an entire data center. Here's an interesting topic: direct attached storage, or DS. Imagine it like a super-fast, dedicated hard drive plugged right into one specific server, providing local storage access. Since there's no network involved, you get ultra-low latency, making it perfect for dedicated database servers that demand really fast local I/O performance. It's a cost-effective solution and quite simple to set up. However, its main limitation is that you can't share access across multiple systems, and it presents a single point of failure risk if that one server goes down. It's great for specialized, focused needs. Let's discover network-attached storage, or NAS, which is essentially your own personal or business cloud, right there on your network. Think of it as a dedicated file server, a central hub where multiple users can access shared files simultaneously. This makes it perfect for collaborative environments, like when your team is working on a big presentation and needs seamless file exchange. It offers centralized management and is quite cost-effective for small to medium businesses, though its performance can sometimes be limited by your network's bandwidth. It's truly a game changer for organizing and sharing data efficiently. Let's unpack what a storage area network, or SAN, truly is. Essentially, it's a dedicated, high-speed network just for storing data at a block level. Servers connect to it and genuinely perceive this shared storage as if it were a local disk, simplifying application management. This setup provides exceptional throughput and minimal latency, making it ideal for mission-critical applications. You gain incredible scalability, easily expanding storage capacity without disruption, and robust reliability through multipath failover for continuous availability. While it's a complex setup with higher costs, the performance benefits are significant. Let's get into the fundamental difference between file and block storage. Think of file storage like a well-organized digital filing cabinet. Data is neatly arranged as files and folders, easily accessed via network protocols like NFS or SMB. It's perfect for shared documents and media, making collaborative workflows simple. Block storage, on the other hand, gives your operating system direct access to raw storage blocks, almost like a blank canvas. Your OS then formats and manages these blocks, making it incredibly fast and flexible for demanding applications such as databases or virtual machines, because it's treated like locally attached storage. Let's explore the concept of data redundancy, which is essentially about protecting your valuable information from loss. Think of it like having multiple backup plans for your critical files. We use things like RAID technology to achieve this, distributing data across multiple disks. This ensures what we call fault tolerance and guarantees data availability. So if one disk decides to give up, your data is still safe and accessible from another, minimizing downtime and data loss risks. For instance, a RAID 6 configuration is so robust, it can even tolerate 2 simultaneous disk failures without any data loss. Pretty clever, right? Let's consider storage performance, which really boils down to 2 key metrics: IOPS and throughput. IOPS, or input-output operations per second, measures how many quick read/write operations a system can handle, essential for transactional workloads. Throughput, on the other hand, measures the amount of data transferred per second. Think of it for large file transfers or streaming. Different storage types are optimized for this balance. DAS offers highest IOPS due to its direct connection, while NAS is typically optimized for throughput in file sharing scenarios. Performance tuning means understanding and balancing these based on your specific workload requirements. Let me guide you through the crucial world of data growth and capacity planning, which is essentially about preparing for tomorrow's demands. We're experiencing explosive growth in data globally, seeing increases of 30–40% annually, largely thanks to AI workloads and the vast number of IoT devices. It's like your digital storage needs are constantly expanding. To manage this, we first assess current usage, then forecast growth trends to predict future needs. Next, we plan scalable architecture, think SAN or NAS solutions, allowing flexible expansion without downtime. Finally, constant monitoring and optimizing ensures we're efficient and control costs. Let's look at how we approach choosing the right storage, which really boils down to understanding your specific needs. We assess your workload first. Do you need dedicated low-latency direct-attached storage (DAS) for a single server, or perhaps network-attached storage (NAS) for easy file sharing and collaboration across a team? For high-performance, mission-critical applications requiring scalable block storage, a storage area network (SAN) is often the optimal choice. It's vital to understand the distinction between file and block storage protocols here, and always factor in robust redundancy strategies like replication for ultimate data protection. I hope you found this information valuable, and thank you for your attention and participation. Welcome. I'm excited to share some interesting concepts with you. Let's start by looking at server operating systems, which are truly the unsung heroes behind almost everything we do online. Think of them as the powerful brain of a data center, forming the absolute backbone of enterprise IT infrastructure. They manage resources, store data securely, and keep all those critical applications running smoothly 24/7. Without these specialized operating systems, our digital world simply wouldn't function, making them indispensable. Let's examine what a server operating system truly is. Think of it as the specialized brain running powerful computers called servers. Unlike your personal computer's OS, which focuses on a single user, a server OS is engineered for exceptional stability and robust security to efficiently manage resources for many users and services simultaneously across a network. It's the critical backbone supporting essential infrastructure like your website, email, or database, ensuring everything runs smoothly 24/7 for businesses and their clients. Here's an interesting topic. Windows Server, Microsoft's operating system designed for businesses, really shines because of its user-friendly design and incredible integration. Think about it. It works seamlessly with services you might already use, like Active Directory or Office 365, simplifying management. It's packed with enterprise features, too, offering robust security and advanced virtualization with Hyper-V. This makes it perfect for corporate IT environments, especially since it also comes with reliable support and regular updates. It's truly built for organizations prioritizing ease of use within the Microsoft world. Let's explore the concept of Linux servers, which are truly the backbone of the internet, with an incredible 96% of web servers running on Linux infrastructure worldwide. It's a powerful open-source, Unix-like operating system that dramatically reduces expenses because the core cost for most distributions is often $0. What makes it so popular is its exceptional flexibility and robust security, offering unmatched customization capabilities for virtually every use case. While it does require a bit more technical expertise, you're never alone thanks to its vast, active community providing continuous support and innovation. Let's explore the concept of client OS versus server OS, which are fundamentally different despite both being operating systems. Think of a client OS, like the Windows on your home computer, as being designed for a single-user desktop experience, perfect for personal productivity and entertainment. It has limited concurrent user support and basic security. A server OS, however, is built for 24/7 operation and maximum reliability, optimized for multi-user access and managing network resources. It includes advanced security, backup, and remote management tools. It's like comparing a personal car to a heavy-duty truck, each built for a very specific purpose. Here's an interesting topic. Understanding different server roles is pretty crucial in tech. Think of a file server as your team's central digital filing cabinet, providing centralized storage so everyone can easily share documents and media files. Then, a web server is what serves up all those websites and web applications you browse daily. And for managing crucial structured data, you've got a database server, which powers business-critical applications. What's cool is that modern server operating systems often run multiple of these roles simultaneously on powerful hardware, maximizing resource utilization and making things super efficient. Let me introduce you to the unsung hero of many businesses, a powerful server OS. Imagine one central machine that effortlessly handles multiple crucial roles simultaneously. It's the hub where employees access shared documents for collaboration, the host for your company's website where customers browse, and the brain behind your applications querying data for real-time operations. This single server OS keeps everything running smoothly, serving dozens or hundreds of client devices while expertly maintaining security, performance, and reliability across the entire network infrastructure. Let's talk about server software licensing, which isn't a one-size-fits-all concept. Models vary significantly, often tied to things like the number of users, processor cores, or physical/virtual machines. Take Windows Server, for example. You'll often need client access licenses, CALs, on top of the base server license for user or device access. Contrast that with many Linux distributions, which are free to use, though enterprise versions offer crucial paid support. Ultimately, these licensing choices profoundly impact your total cost of ownership, available support, and compliance requirements. Let's unpack why selecting the right server OS is such a big deal. It's not just about what runs your applications. It directly impacts your system's security and performance, which are absolutely crucial for your operations. You also have to consider the total cost of ownership, which goes way beyond initial licenses to include ongoing maintenance, support, and the technical expertise required to manage it. Plus, there's strategic alignment with your internal skills and budget, and even future-proofing to ensure it works with emerging technologies. It's truly a multifaceted decision that requires careful thought. Let me help you understand that at the core of nearly every business, server operating systems like Windows Server and Linux are the true workhorses, powering critical network services. These are the two dominant players, each offering distinct strengths, licensing implications, and learning curves. Choosing between them is a significant strategic decision-making process. You need to consider your specific organizational needs and what server roles are required to truly optimize IT infrastructure investments. That concludes our session for today. Thank you for your focus, and I hope this was beneficial for you. Hello everyone. I hope you're doing well, and welcome to this learning session. Today, we're going to explore the exciting world of virtualization fundamentals. Essentially, it's a game changer that allows us to take one powerful physical computer and create multiple independent virtual computers, each with its own operating system and applications. Think of it like a smart apartment building where many families live comfortably on one piece of land. This incredible technology is truly unlocking modern IT efficiency by maximizing resource use, saving costs, and making everything much more flexible and manageable. It's about getting more from less. Let's discover how virtualization is like magic for computers. Imagine you have one super powerful physical machine. Instead of using it for just one job, virtualization lets you create many virtual versions of that machine, called virtual machines or VMs. It cleverly abstracts hardware like CPU and memory, making each VM act like an independent computer. This means one server can host several operating systems and applications, all running simultaneously in their own isolated environments. It's incredibly efficient, like turning a single building into multiple distinct offices, each with its own setup. What we're looking at here is how hypervisors, essentially virtual machine managers, allow us to run multiple operating systems on one physical machine. Think of it like a smart conductor for your hardware. We have two main types: Type 1, or bare metal, which runs directly on physical hardware for top-tier performance and security, perfect for big enterprises. Then there's Type 2, which runs on top of a host operating system, like an app on your computer, making it easier to set up and great for testing, though with some performance overhead. Both dynamically allocate hardware resources and isolate VMs, ensuring stability. Let's consider the incredible benefits of virtualization, which really transforms how we manage computing resources. Instead of having many underutilized physical servers, virtualization lets us create several virtual machines on just one piece of hardware, boosting hardware utilization from a typical 10 to 50% to 80% or more. This directly leads to huge cost savings because we buy less hardware, consume less energy, and reduce maintenance efforts. It also offers amazing flexibility, like being able to rapidly provision new systems or perform live migration with near zero downtime. And for security, each virtual machine is isolated, so a problem in one won't affect any others. It's a truly smart way to be efficient. Let me guide you through the exciting world of servers, contrasting physical and virtual machines. Imagine a traditional physical server as a single computer dedicated to one task, like an office building with just one company inside. Its hardware is fixed, making deployment and scaling slower. Now picture a virtual machine. It's like having multiple separate offices, each running its own operating system, all within that same physical building. These are essentially portable files, making them easily moved or copied, which means incredibly faster deployment and much better disaster recovery. This transformation truly gives organizations unprecedented agility and resilience in their IT operations. Let's explore the concept of how we smartly allocate resources in a virtualized environment. We essentially give each virtual machine VM its own slice, a vCPU, from the underlying physical CPUs. Similarly, RAM is allocated per VM but shared across the host, and virtual disks are created from physical storage pools. The clever part is overcommitment, assigning more virtual resources than physically exist. This works because not all VMs need their full allocation simultaneously. The hypervisor cleverly manages this contention, ensuring fair performance by understanding typical workload patterns. It's incredibly efficient. Let's talk about virtual networking, which is essentially creating entire network infrastructures in software rather than just hardware. Think of virtual switches like the traffic cops for your virtual machines, VMs, connecting them internally and to external networks, just like physical switches do for computers. We also use virtual LANs or VLANs to segment traffic. This is incredibly handy for enhancing security and optimizing performance, maybe by keeping your web server's traffic separate from your database servers. Cloud providers use these exact tools for network isolation, allowing them to securely isolate thousands of tenants on the same physical infrastructure, without anyone getting into each other's business. It's pretty clever how it all works. Let me show you how virtual storage really simplifies things. Imagine you have a bunch of different physical hard drives. We can combine them into a single big storage pool, treating them as one logical unit. Your virtual machines then don't see those individual drives, but virtual disks, which are essentially just files like VMDKs, abstracting the physical storage underneath. We use SAN and NAS as the network architectures to deliver this storage to our VMs. Plus, powerful features like snapshots and cloning allow for quick backups and easy VM replication. It's all about achieving unprecedented flexibility and software-defined efficiency in managing your data. Here's an interesting topic. Virtualization essentially lets one physical computer act like many separate, independent machines. Imagine enterprise data centers using shared hardware to host thousands of websites, only charging customers for their consumed resources while maximizing infrastructure efficiency. It's also the secret sauce behind cloud computing platforms like AWS, enabling truly infinite scalability and secure multi-tenancy across their global systems. This powerful concept really transforms IT operations, making everything far more flexible and helping organizations significantly reduce costs. Let me show you how virtualization is truly advancing. We're seeing massive traction with containerization, which offers a super lightweight virtualization approach, almost like shipping a self-contained application box that runs anywhere effortlessly. Then, hardware acceleration, like Intel VTX and AMD V technologies, directly enhances performance, making everything run smoother. Edge computing is another exciting area, bringing these virtual environments closer to data sources for faster local processing. Plus, there's a strong focus on advanced security, with improved isolation models keeping things safer than ever. Really, mastering virtualization fundamentals is the key to unlocking modern IT innovation and efficiency. That concludes our session for today. Thank you for your focus, and I hope this was beneficial for you. Welcome everyone. I'm thrilled to help you learn. Today's topic is all about networking fundamentals for servers. Think of a server as a specialized computer designed to provide services or share resources, like a digital library or a powerful chef. For that server to actually do its job, whether it's hosting a website or storing files, it absolutely needs to communicate with other devices. Networking is precisely that communication system. It's the backbone of connectivity. Without it, your powerful server is just an isolated box, unable to share its amazing capabilities with anyone, anywhere. Let's unpack how devices truly find each other on a network. Every gadget has a unique, permanent MAC address like a hardware serial number, allowing them to recognize each other locally. But for broader reach across the internet, we use IP addresses, global identifiers for your device. The magic happens with ARP, the Address Resolution Protocol, which translates an IP address into its corresponding MAC address when devices need to chat within their own local network. It's the essential bridge for seamless communication, ensuring that packets always find their way home, whether next door or across the globe. Let's discover how switches and routers act like the crucial traffic controllers of networks. Switches are essentially like local traffic cops, connecting devices within the same network and directing data efficiently at the local level based on MAC addresses. Routers, however, are the master navigators. They connect different networks entirely, making intelligent routing decisions to find the best path for data to travel across the internet or between LANs and WANs. So switches handle local connections, while routers connect entire networks and make those vital path decisions. Let me help you understand network boundaries simply. A local area network (LAN) is like your home Wi-Fi, providing high-speed connectivity within a limited geographic area, perhaps an office building. Now, if you connect multiple LANs together over large geographic distances, spanning cities or continents, you're looking at a wide area network, WAN, with the internet being the biggest example. Then there's a virtual LAN VLAN. This is clever because it lets you logically segment a single physical LAN, creating separate broadcast domains for enhanced security and efficiency, all without needing additional hardware. It's like having distinct virtual rooms within one big physical space. Here's an interesting topic. Have you ever wondered how your computer finds a website when you type something like google.com? It's all thanks to DNS, which is often called the Internet's phone book. Instead of us having to memorize complex numeric IP addresses for every single service we want to visit, DNS translates those user-friendly domain names into the numbers servers understand. This amazing system is actually a global, distributed infrastructure, ensuring fast and reliable name resolution so we can access virtually anything online without a second thought. Let's examine DHCP, or Dynamic Host Configuration Protocol. Simply put, it's the network's automatic administrator for assigning digital addresses. Instead of you or I manually configuring every device that joins our network, DHCP steps in. It automatically assigns IP addresses and network configuration settings to anything that connects, whether it's your laptop or a new printer. This brilliant system reduces manual configuration errors significantly and makes network management much simpler, especially in larger environments. Think of it as a helpful concierge ensuring seamless network access for every guest, giving them what they need without fuss. Time to understand firewalls, which I like to think of as vigilant gatekeepers for your network. They continuously monitor and control all incoming and outgoing network traffic, acting like a bouncer who checks IDs based on predetermined security rules. This essential traffic monitoring protection layer is crucial for safeguarding your servers and systems from unauthorized access, malicious attacks, and various cyber threats. We even have different kinds, from basic software versions to advanced next-generation firewalls that perform deep packet inspection to catch hidden dangers. Let's consider how vital load balancing is in our digital world. Imagine a popular website with millions of visitors. Without it, a single server would quickly become overwhelmed and crash. Load balancers intelligently distribute incoming network or application traffic across multiple back-end servers. This clever distribution ensures no single server becomes overwhelmed, dramatically improving uptime, response times, and user experience. It's like having a traffic controller for your data, directing requests evenly to prevent bottlenecks. This is essential for maintaining high availability and fault tolerance in modern web services and cloud infrastructure, ensuring everything runs smoothly. Let's discover how your online requests, like clicking a link, actually travel through the internet's complex dance. It's an incredible journey. First, your local switch handles local routing within your immediate network. Then, a router takes over, making crucial path selection decisions across the vast internet. Before reaching a website, a DNS lookup acts like a phone book, resolving the server's real address. A vigilant firewall then performs a vital security check. Next, a load balancer steps in for server selection, distributing traffic efficiently. Finally, the server response delivers your requested data, ensuring it arrives securely and quickly. Let's unpack networking fundamentals, because understanding concepts like IP addressing, how routing works, and key network services is absolutely essential for reliable, scalable server operations. Think of them as your server's GPS and communication backbone. Mastering these practical skills empowers you to design robust network architectures, troubleshoot swiftly, enhance your security posture, and optimize performance, even as protocols evolve. This is truly foundational. That concludes our session for today. Thank you for your focus, and I hope this was beneficial for you. Hi everyone. Welcome to our learning session. Today we'll be working with Identity and Access Management, or IAM. Essentially, it's about making sure the right people have the right access to the right things. Imagine it like a digital security guard and a guest list for all your valuable resources. IAM is crucial for securing digital trust by applying intelligent identity governance and access control. This system verifies who you are, your identity, before granting you permission, ensuring only authorized users can interact with our data and systems safely. It truly protects our digital world. Let's talk about why identity and access management, or IAM, is absolutely critical today. Think of it like a bouncer at a club, but for your digital world, ensuring only the right people, and even machines or software, get into the right resources at the right time. Without IAM, it's an open door for trouble. Sadly, a huge chunk of cyber attacks, around 30% according to IBM X-Force, start with stolen or misused credentials. Beyond just stopping breaches, IAM helps us meet compliance rules and is truly the foundation for modern security strategies like Zero Trust. It's about protecting everything. Let me introduce you to two essential security gatekeepers: authentication and authorization. I like to explain it simply. Authentication is all about verifying who you are. Think of it as showing your ID at the door, proving you're the person you claim to be, often with a username and password or even a fingerprint. Once you're identified and allowed in, authorization then steps in, determining what you can do. Can you access the VIP area? Can you adjust certain settings? These are your specific access permissions and rights. Both are absolutely critical to prevent unauthorized access and keep everything secure. Let me walk you through what makes Active Directory so essential. Think of it as the central nervous system for almost every major company's computer network. It's a huge, organized directory, like a digital phone book, that neatly stores all user accounts, groups, and security rules. When you log in, it uses secure protocols like Kerberos to confirm you are who you say you are. Plus, it plays super nicely with cloud services through Azure AD, creating seamless single sign-on experiences whether your data is on-premise or in the cloud. It truly is the backbone of identity and access management. Let's break down how access control truly works. We have users, which are individual identities like you or me, or even a service. To make life easier, we put these users into groups, collections organized for simplified permission management. Then, permissions are the specific rights assigned to these groups, or individual users, that control access to resources and dictate what actions they can perform. Imagine your finance team group automatically getting access to sensitive budget spreadsheets, while the marketing team group only sees campaign files. It's brilliantly efficient for security and productivity. Here's an interesting topic: role-based access control, or RBAC. Imagine a company where instead of individually assigning permissions to everyone, you group them by what they do. RBAC assigns permissions based on predefined roles, so an editor role automatically gets content modification rights, while a viewer just has read-only access. This approach, centered around job function, dramatically simplifies administration and reduces errors. It's incredibly helpful for enforcing the principle of least privilege, ensuring people only access what they need, which is great for supporting regulatory compliance and audits. Let me show you what the principle of least privilege is all about. Essentially, it means giving users only the minimum access necessary to perform their specific job tasks. Nothing more, nothing less. Imagine a delivery driver who only gets the key to the back door, not the entire house. This drastically limits damage scope if their key is lost or stolen, protecting other sensitive areas from being compromised. It's about minimizing risk exposure. And crucially, we need continuous review to ensure these permissions stay appropriate as responsibilities change. Let's explore the concept of how systems manage who can do what, often called identity and access management. Imagine you're entering a secure building. First, you verify your identity with a keycard or fingerprint. That's user authentication. Once inside, the system knows your role. Are you an employee, a visitor, or a manager? Based on that role, specific policies dictate what doors you can open or resources you can access. If you try to enter a restricted area, permission enforcement kicks in, blocking unauthorized requests. It ensures only authorized users gain access, keeping everything secure and accountable. Let's talk about modern identity and access management, IAM, and its interesting landscape. We've certainly moved beyond simple passwords, widely adopting multi-factor authentication, MFA, to truly strengthen authentication by combining something you know, have, and are. This is vital, especially with infrastructure spanning cloud and hybrid environments, needing federated identity management and single sign-on, SSO, for seamless access. It's also not just human users anymore. Machine identities and workload identities are a growing complexity. Ultimately, it's always about balancing robust security controls with user convenience and operational efficiency. Let's examine identity and access management, IAM. the critical foundation for secure digital transformation. IAM strategically protects your assets, ensures compliance, and enables innovation. We implement core principles like role-based access control, RBAC, and least privilege policies to systematically reduce your attack surface. Utilizing proven tools such as multi-factor authentication provides robust identity governance, safeguarding your digital future. That brings us to the end of our session. Thank you for your wonderful attention, and I hope this was helpful. Hi friends, I'm delighted to have you with me. Let's begin our journey into IT infrastructure security, which is essentially about protecting the digital backbone of any organization. Think of it like safeguarding the very nervous system and skeleton of a complex entity. We create robust defense layers, from the physical safeguards like locked server rooms and access controls, all the way to intricate digital monitoring systems that constantly scan for threats online. It's a comprehensive approach to ensure our essential digital world stays secure and operational against any challenge. Let's explore the concept of server security and why it's incredibly vital. Servers are the digital backbone of most businesses, holding all that mission-critical data and the applications that keep everything running smoothly. A single successful cyber attack can be devastating, leading to millions in financial losses, hefty regulatory fines, and long-term damage to a company's reputation. It's a constant battle, too, as cybercriminals are always developing more sophisticated methods to compromise these environments. We really need to protect these systems because the stakes are incredibly high, affecting nearly half of all cyber attack targets. Let me introduce you to a foundational concept often overlooked: physical security. Imagine building an impenetrable digital fortress, only for someone to simply walk through an unsecured door. That's why it's your first line of defense. Even the most sophisticated digital protections crumble when physical access is compromised. We employ measures like biometric access controls, using fingerprints or retina scans, to ensure only authorized personnel can enter. Add continuous 24/7 surveillance and reinforce server rooms, and you create a robust perimeter, safeguarding against the very real threat of data theft or hardware tampering that stems from unauthorized entry. Let me explain. Network security is essentially about building robust, protective barriers around your digital information as it travels, preventing interception and malicious attacks. Without proper defenses, sensitive data becomes incredibly vulnerable. We deploy various tools. Firewalls act like digital bouncers, filtering traffic, while intrusion detection systems constantly monitor for suspicious patterns. We even segment networks into isolated zones to limit movement if a breach occurs. It's a comprehensive approach, increasingly moving towards an identity-based security model like Zero Trust, where trust is never assumed, only verified. Let me guide you through the crucial concept of server hardening. Think of it like meticulously building a fortress around your digital assets. We systematically reduce potential attack surfaces by proactively eliminating vulnerabilities before they can ever be exploited. This means transforming those often weak default server configurations into truly resilient security barriers. It involves practical steps like disabling unnecessary services, enforcing strong authentication, and setting up secure defaults. By doing this, we effectively stop bad actors in their tracks, significantly reducing exploitable weak points and protecting your valuable data. Let me introduce you to patch management, a truly critical security practice. Think of it like a constant effort to close vulnerable doors and windows in your software before someone breaks in. Attackers are actively scanning for these security flaws, and the window between a vulnerability being known and widespread exploitation has shrunk dramatically. That's why we meticulously test and deploy security updates or patches as quickly as possible. Delaying creates exploitable windows that attackers eagerly target, and frankly, unpatched systems are behind a huge number of breaches. Let's discover how modern endpoint protection acts like a sophisticated digital immune system for your business. It's so much more than just traditional antivirus, which often only catches known problems. Instead, it's an intelligent defense system that uses AI behavioral analysis to detect even brand new, zero-day threats by noticing unusual system activity. It proactively hunts for hidden issues and even prevents ransomware by monitoring suspicious file modifications, protecting your infrastructure from what could be a catastrophic breach. This advanced approach keeps your systems safe, like a vigilant security guard anticipating danger. Let's examine logging and auditing, which I like to think of as your system's security black box. Just like in aircrafts, it continuously records every critical event, user activities, network connections, and configuration changes. This immutable audit trail is incredibly valuable. When something goes wrong, detailed logs allow for forensic investigation to understand exactly what happened, how attackers gained access, and what data may have been compromised. Plus, advanced analytics can spot unusual patterns for real-time threat detection. It's also crucial for compliance verification, proving adherence to regulations. Essentially, it transforms raw data into actionable security intelligence. Let me introduce you to the smart way to build security through an integrated ecosystem. Think of it like a castle with multiple, overlapping defensive layers. Not just one wall, but physical security, strong network defenses, and even endpoint protection. No single control provides complete protection. True resilience comes when these layers work together, stopping attacks even if one fails. Even better, modern infrastructure as code security embeds security policies directly into your infrastructure automation. This ensures consistent, auditable deployments with security controls built in from the start, effectively eliminating configuration drift and human error. It's security by design. Time to understand how we build resilient IT. We begin with robust physical and network foundations. Then we rigorously harden systems and automate patching to reduce attack surfaces. Advanced endpoint protection, often AI-powered, detects known and zero-day threats. Continuous logging and monitoring provide vital visibility for rapid incident response. Remember, security is truly a journey. Threats evolve continuously, so our defenses must too. That brings us to the end of our session. Thank you for your wonderful attention, and I hope this was helpful. Hello everyone, I hope you're doing well, and welcome to this learning session. Today, we're going to explore offensive security. Imagine you're trying to protect a fort. To do that really well, you wouldn't just build walls. You'd also try to figure out every possible way an enemy might attack. That's exactly what thinking like an attacker means in cybersecurity. By proactively exploring vulnerabilities and simulating potential threats, we can understand how bad actors operate, allowing us to strengthen our organization's defenses much more effectively and protect our systems before a real breach occurs. Let's break down offensive security. It's a really smart, proactive cybersecurity strategy where we essentially pretend to be the bad guys. Instead of just waiting for an attack, we actively simulate real-world attacks to uncover vulnerabilities and security gaps before malicious actors exploit them. Think of it as ethical testing. We're trying to find weaknesses in systems through things like penetration testing or red teaming exercises. The goal? To truly strengthen organizational defenses, reduce risk, and build a more security-aware culture. It's about being one step ahead. Let's consider how attackers truly target servers. It's not a shot in the dark. They employ systematic approaches, much like a meticulous planner. They begin with a thorough reconnaissance phase, scanning for open ports, outdated software versions, and exposed services to really map your network topology. This helps them pinpoint potential attack vectors. Once they've gathered this intelligence, they move to exploitation, often leveraging weak configurations, a big culprit in cloud server attacks, or those pesky unpatched vulnerabilities to gain unauthorized access. They're essentially doing their homework to find the path of least resistance. Let's get into why even well-intentioned organizations sometimes create their own security headaches. Often, it boils down to common infrastructure misconfigurations, essentially security settings not being quite right. These errors are the low-hanging fruit for attackers because they're easily exploited. We're talking about simple things like leaving default credentials unchanged on critical systems, or having exposed management ports like SSH directly accessible from the internet without proper controls. Firewall misconfigurations with overly permissive rules also create unnecessary pathways for attackers. And don't forget unsecured APIs lacking authentication, which can inadvertently expose sensitive data. It's all about diligence. Now let's dive into why passwords remain the primary target for attackers, and often the weakest link in our security. It's truly eye-opening how many breaches involve compromised credentials. Attackers might use brute force or credential stuffing, essentially automated attempts to log in using commonly known or previously stolen passwords. Then there's phishing and social engineering, which cunningly manipulate users into revealing their login details through deceptive emails or fake pages. A sneakier one is password spraying, where they test a single common password across numerous accounts to fly under the radar. Knowing these methods helps us implement stronger defenses. Now, let's dive into why adopting an attacker's mindset is absolutely critical for anyone in security. It's like being a chess player who thinks several moves ahead, not just reacting to what their opponent does. By understanding attacker tactics and potential attack techniques, we can proactively reveal hidden vulnerabilities that automated tools might miss. This shifts us from simply patching after a problem to enabling proactive defense, where we identify and secure potential weak points before exploitation can even occur. It drastically improves incident response and fosters continuous improvement in our overall security posture. Let me show you how we constantly navigate the critical trade-off between security and usability. Think about it. Robust security controls, like multi-factor authentication or complex password requirements, are vital for protection. But if they create too much login friction or hinder quick system access, users get frustrated, find workarounds, and productivity suffers. The challenge is real. The key is finding that balance, maybe even with adaptive authentication that adjusts to the risk, so we get both protection and productivity without unnecessary friction. Let's unpack why offensive security is so incredibly valuable. Think of it like hiring a professional burglar, a red team, to deliberately test your home's security, actively trying to find weak points. This approach goes beyond what automated scanning tools can do, uncovering critical vulnerabilities in your systems, or even in employee awareness that might otherwise be missed. By proactively identifying these issues through simulated attacks, organizations can make targeted improvements, significantly reducing breach likelihood. It's not just a theoretical concept. It delivers measurable protection against real-world threats, preventing potentially multi-million-dollar incidents before they ever happen. Let me walk you through why security isn't just a tech problem, but a vital cultural change. It means every employee becomes part of the defense strategy. We achieve this by educating staff with employee training programs to recognize attack methods, significantly reducing human error vulnerabilities. Then we reinforce safe behaviors through simulated attack exercises, like phishing drills. By fostering cross-functional collaboration and continuous resilience building, employees transform from potential weak links into active defenders, multiplying your overall protection. Here's an interesting topic. Understanding offensive security is absolutely essential today, not a luxury. It's about adopting an attacker mindset, thinking like the bad guys so we can build stronger, more resilient defenses. This proactive approach allows us to find and fix vulnerabilities before they're exploited, because prevention always beats remediation. We also need to balance strong security with usability for effective protection. I appreciate you taking the time to learn with me today. I hope this content was useful and engaging. Hello and welcome. It's a pleasure to guide you through this material. We'll be focusing on protecting your business continuity. Essentially, ensuring your operations never truly stop. Think of it like this. Backup is having a spare tire for your car. You've got copies of your crucial data. Availability means that car is always running when you need it, and your systems are accessible. Should a disaster strike, disaster recovery is your well-practiced plan to quickly get back on the road. These three components are absolutely vital for any business to stay resilient and functional. Let's get into why backups are truly the foundation of data protection for any organization. Think of them as your business's ultimate safety net. Without reliable backups, even common issues like an accidental deletion, file corruption, or a nasty ransomware attack can bring operations to a grinding halt. This isn't just an IT headache. It means devastating revenue loss and completely erodes customer trust. Backups are more than just a checkbox. They're the lifeline that allows your organization to quickly recover and continue serving customers when disaster inevitably strikes. Let me show you the three primary backup types and why understanding them is key. A full backup is a complete copy of all your data, which means it takes the longest backup time and uses the most storage, but offers the simplest restore process. Then we have an incremental backup, which is super efficient because it only captures changes since the last backup of any kind, resulting in the fastest speed and smallest storage. However, restoration can be more complex. Lastly, a differential backup provides a balanced approach, saving all changes since your last full backup, offering moderate speed and storage with a simpler restoration than incremental. Let's look at why simply having one backup isn't enough. We have on-premises storage for quick, lightning-fast recovery, but a single fire or localized disaster could destroy everything. Off-site physical backups protect against such site-wide disasters, like a flood at your main site, but getting that data back takes time. Cloud backup offers amazing scalability and access from anywhere, yet relies completely on your internet connection. That's why the 3-2-1 rule is key. 3 copies on 2 different media types, with 1 copy off-site, truly safeguarding your precious data against multiple risks. Let me walk you through how crucial it is to keep systems running smoothly. Redundancy is the foundation, like having duplicate critical components. Think multiple power supplies or servers. This eliminates single points of failure. However, true high availability HA takes it a significant step further. It's not just having extra parts. It's about having automated failover mechanisms, health monitoring, and load balancing, actively ensuring that if one component fails, another instantly takes over. Imagine HA as a backup pilot already in the cockpit, ready to fly the plane, while redundancy is just an extra plane in the hangar. This active approach guarantees near-zero downtime, achieving that impressive 5 nines uptime. Let's break down disaster recovery. It's essentially your organization's blueprint to restore IT systems after major disruptions, from hurricanes to ransomware attacks. First, you define a clear DR strategy by prioritizing your applications based on business criticality, deciding what absolutely must recover first. Then you establish precise, step-by-step recovery procedures for each. But here's the kicker: you must test regularly. As the saying goes, hope is not a strategy. Annual or quarterly DR testing transforms those theoretical steps into practice muscle memory, ensuring your plan works flawlessly when seconds truly count. Let me walk you through RPO and RTO, which are crucial for any recovery plan. Think of RPO, or Recovery Point Objective, as the maximum amount of data your organization can afford to lose, measured in time. Basically, how fresh your backups need to be. Then there's RTO, or Recovery Time Objective, which is the maximum acceptable downtime before systems must be fully operational again. Balancing these 2 objectives truly drives technology decisions. A financial trading platform, for example, needs extremely tight RPO/RTO, demanding frequent backups and automated failover, which translates to higher investment, unlike a simple, less critical internal website. Let me introduce you to business continuity, which is truly a holistic approach to ensuring your entire organization keeps running smoothly, even through disruptions. Many mistakenly think it's just about restoring technology and data, what we call IT recovery. But it extends far beyond backing up servers. Imagine considering everything from ensuring your people can work, whether remotely or in alternative facilities, to maintaining vital supply chain relationships and keeping stakeholders informed. It's about proactively managing risks and keeping the whole business heartbeat strong, not just the IT systems. Time to understand that downtime isn't just an inconvenience. It's a potential catastrophe for any business. We've seen firsthand how a major online retailer can face massive revenue loss per hour, or a healthcare system can struggle when patient records are inaccessible. The core idea is simple. Robust backup and recovery strategies aren't just about hoping for the best. They're about creating operational resilience. Companies with these mature systems don't just survive. They truly thrive, turning quick recovery into a competitive advantage, preserving their reputation, and maintaining crucial customer loyalty. It's an investment that pays for itself many times over. Here's an interesting topic: building robust backup and recovery systems, which are truly your first line of defense against data loss. It's vital to define your RPO and RTO. Essentially, how much data your organization can tolerate losing, and how quickly you need critical systems operational again after an incident. This informs your comprehensive backup strategy, combining different approaches like full or incremental across various locations. But remember, an untested plan is no plan at all. Regular drills are essential. This isn't just about IT, it's about holistic business continuity. I appreciate your dedication to learning. I hope this was enlightening and thank you for being here. Good day, everyone. I'm glad you're here. Today we'll be examining the critical connection between monitoring our IT systems and understanding their performance. Think of it like a doctor checking your vital signs. By constantly monitoring various aspects of our technology, we gain insight into how well it's performing. This continuous observation is absolutely essential for ensuring the overall reliability of our systems, meaning they work when we need them, and boosting their efficiency so they run smoothly without waste. Without it, we're essentially flying blind. Let me guide you through why IT monitoring is absolutely crucial. Imagine your IT systems like a car's dashboard. Monitoring acts as that constant check, alerting you to potential issues before they cause a breakdown. This transforms our approach from reactive firefighting, only fixing problems after users complain, to true proactive management. We gain real-time insights and continuous visibility, allowing us to detect issues early. This dramatically reduces downtime, avoiding significant expenses through faster troubleshooting and ensuring peak system performance. Ultimately, it empowers teams to make smarter, more informed resource decisions. Let's consider how crucial it is to monitor the vital signs of your IT environment to keep everything running smoothly. Think of it like a car's dashboard. We closely watch the CPU, which tracks the processing load, to prevent system slowdowns or detect runaway processes. Similarly, RAM monitoring reveals memory usage patterns, helping us catch performance bottlenecks and identify memory leaks before they disrupt things. We also keep an eye on disk for I/O performance and capacity thresholds, preventing data loss. And for the network, we analyze bandwidth and latency, ensuring smooth data flow and detecting congestion early. It's all about proactive health checks. Let me guide you through the crucial difference between availability and performance monitoring. Think of availability as simply asking, is the system up? Can users even connect and reach it? We're checking for uptime and accessibility, making sure the door is open. Now, performance is about how well it's running once you're connected. Is it fast and responsive or frustratingly slow? We measure things like response time to ensure a quality user experience. Both are truly essential, because an available system without good performance means a slow, frustrating experience that damages productivity. Let's consider alerts and thresholds as your essential early warning system. By setting smart thresholds, perhaps based on historical data or what really impacts your business, like a CPU exceeding 80% for 5 minutes, you create critical tripwires. When these are crossed, instant notification allows teams to respond rapidly. This proactive approach prevents minor issues from escalating into major outages. It's crucial, however, to tune thresholds carefully and prioritize critical alerts to avoid alert fatigue, ensuring your team maintains focus and effectiveness when it truly matters. Let me introduce you to capacity planning, a crucial concept for any operation. It's all about how we predict, prepare, and prevent issues by smartly aligning resources with demand. Think of it like anticipating a busy holiday shopping season. You use past sales data and trends, what we call predictive analytics, to ensure you have enough staff and inventory. The real art is finding that sweet spot, balancing cost and risk. You don't want to waste money over provisioning, but you definitely don't want to under-provision and disappoint your customers. It's truly about smart, data-driven decision-making. Let me guide you through the real magic of capacity management. It's essentially about foresight, anticipating your IT needs before they become problems. Think of a busy online store during holiday shopping. A simple disk space issue could cause a major outage, potentially costing millions in lost revenue. But with smart planning and predictive alerts, we prevent that. It's truly about integrating your business growth strategies with technical infrastructure, ensuring your systems scale seamlessly. This approach not only prevents costly downtime, but also reduces overall risk and saves significant operational expenses. Let's look at why systems sometimes fail, often due to issues we can proactively manage with good oversight. We frequently encounter capacity constraints, like when a server's CPU or memory gets completely saturated, causing crashes. Then there are component failures, maybe a hardware fault or a software bug that continuous monitoring helps us detect and address early. Human errors such as a crucial misconfiguration or an untested update are also common culprits for unexpected downtime. And of course, network issues like packet loss can severely degrade user experience. Monitoring helps us catch these anomalies quickly, preventing cascading failures. Time to understand how crucial real-time monitoring dashboards are for any system. Imagine them as the ultimate command center for your IT environment, giving you the immediate pulse of its health and performance. They offer instant visibility, consolidating all system vitals into one intuitive interface, making everything easy to grasp. You'll see clear, color-coded alerts and thresholds that instantly identify issues, like a traffic light telling you, red means stop. Beyond just the now, These dashboards track historical trends and patterns, enabling powerful predictive analysis so you can foresee and prevent problems before they even impact users. Let me walk you through why intelligent IT monitoring is your strategic advantage. It's about moving beyond just reactive firefighting. Instead, we want to establish meaningful alerts and implement capacity planning. This proactive strategic management builds truly resilient systems, giving us continuous insight and foresight. It's like having a crystal ball for your IT, preventing issues before they impact business growth. Embracing smart monitoring tools today ensures a more stable tomorrow. I'm grateful for your presence today. I hope you've gained some valuable insights and thank you for listening. Greetings everyone. I'm excited to teach you something new today. Let's explore why IT infrastructure management and operations are the absolute foundations for business success. Think of a successful company like a thriving city. Its IT infrastructure, all the hardware, software, networks, and data centers, is like the essential roads, power grids, and water systems. Effective management ensures these critical components run smoothly and securely, enabling every business function to operate, innovate, and serve customers without a hitch. It's what keeps the entire enterprise moving forward. Now let's dive into why IT infrastructure management is so incredibly vital. Think of it like the nervous system of any business. If it's not healthy and well maintained, everything else struggles. Proactive management isn't just a nice to have. It's essential for ensuring continuous business operations and keeping things always on. This approach drastically reduces operational risks, helping businesses avoid costly downtime that can exceed $100,000 per hour. Essentially, it's about building a robust, secure foundation that supports innovation and future scalability, ensuring everything runs smoothly. Let me show you why change management is absolutely vital for any organization dealing with technology. It's truly about controlling IT evolution, ensuring that every update or new system isn't a chaotic experiment, but a disciplined approach. We meticulously approve, document, and implement changes to minimize disruptions and maintain system stability. Think of it like a carefully planned surgical procedure. You perform an impact analysis to understand potential effects, ensure stakeholder communication, keeps everyone informed, and always have rollback plans ready for quick recovery. This structured process prevents outages and keeps everything running smoothly, making a huge difference in reliability. Let's consider how vital good documentation truly is for IT. Think of it as the backbone of reliable IT operations. Comprehensive records, encompassing detailed system settings and architecture diagrams, provide a quick reference for configurations. Then there are standard procedures, step-by-step guides for common tasks, and incident history, detailing past issues and resolutions. This collective knowledge isn't just convenient. It fundamentally enables faster troubleshooting and seamless knowledge transfer. Ultimately, it significantly reduces downtime and directly improves overall operational efficiency, making everyone's job easier and more effective. Let me walk you through why truly understanding IT asset management is a game changer. Imagine knowing exactly every piece of hardware and software your organization owns, almost like having a perfect inventory of your entire tech arsenal. This systematic tracking is crucial because it immediately prevents overspending. No more buying licenses you already have. It also significantly eliminates security gaps by curbing unauthorized software use and ensures you're always compliant with licensing requirements. Ultimately, mature ITAM provides 100% complete visibility, leading to substantial annual IT cost savings and a much more secure environment. Let's unpack why staying on top of software updates is so crucial for cybersecurity. Think of your digital systems like a house. Neglecting unpatched vulnerabilities is akin to leaving windows open, a huge invitation for trouble. We know from reports that a staggering 60% of breaches exploit these neglected security holes. The simple solution? Automated patch management. By implementing scheduled maintenance windows, we proactively close those gaps, significantly improving system stability and protecting against emerging threats. It's like having a dedicated caretaker consistently ensuring every lock is secure, preventing costly break-ins before they even happen. Let's break down IT asset lifecycle management, which is essentially overseeing assets from their very beginning to their end. It kicks off with procurement, strategically acquiring equipment that aligns with business needs and optimizes budgets. Then comes deployment, getting everything installed, configured, and ready for user enablement. Next, consistent maintenance ensures ongoing support and updates, keeping things running smoothly. Finally, decommissioning handles the secure retirement and data sanitization of assets. This complete cycle extends usability, ensures regulatory compliance, and really optimizes the total cost of ownership, making sure you get the most value. Let me explain how strategic vendor contracts are truly about building powerful partnerships. It's not just signing papers, it's defining expectations. That's why service level agreements or SLAs are so crucial. By negotiating strong SLAs, you ensure things like guaranteed uptime and timely issue resolution, establishing clear accountability for service delivery. This kind of premium support, often found in enterprise contracts, becomes invaluable. Ultimately, managing these vendor relationships strategically dramatically reduces downtime and optimizes spending, directly aligning services with your business needs for real cost control. Time to understand how all the moving parts of IT truly connect. I've seen firsthand that by integrating elements like change management, ensuring a controlled evolution, with solid documentation as our crucial knowledge foundation, and even strong vendor relationships, we build something incredibly robust. Add in smart asset management, consistent patch cycles acting as a vital security shield, and strategic lifecycle planning, and what emerges are genuinely resilient IT ecosystems. This isn't just theory, it's how we practically drive business value, leading directly to improved performance, enhanced security posture, and significant cost efficiency across the board. Let me walk you through why effective IT infrastructure management is crucial for modern business. Think of it as your competitive advantage, enabling true innovation and business agility. By investing in disciplined processes, comprehensive documentation, and strategic partnerships, you build operational resilience. This proactive approach strengthens your security posture and unlocks efficiency gains, strategically positioning your organization for future success. It's been a pleasure guiding you through this content. I hope you found it useful and thank you for joining me. Welcome. I'm excited to share some interesting concepts with you. Let's start by looking at cloud and modern infrastructure. These aren't just buzzwords. They represent the essential foundations of how organizations build and deliver services, shaping the trends we'll see through 2025. Think of it as moving from owning and maintaining all your own power generators to simply plugging into a dynamic, scalable electricity grid. This shift brings incredible agility, efficiency, and resilience, making sure our digital backbones are flexible and ready for future demands. Let me walk you through what cloud computing really is. Essentially, instead of buying and maintaining all your own expensive computer hardware, you can rent computing resources, things like servers, storage, databases, and software, over the internet, on demand. This totally eliminates the need to own physical infrastructure. You just pay for what you use, offering incredible scalability and flexibility. Need more power instantly? You've got it. It's like having a massive utility company for computing. Plus, with advancements like quantum cloud computing and AI-driven security, those capabilities are only accelerating. Time to understand cloud service models like IaaS, PaaS, and SaaS. Think of it as a spectrum of what you manage. With IaaS, infrastructure as a service, you get virtualized hardware resources, handling operating systems yourself. PaaS, platform as a service, offers a managed platform for application development. You just focus on writing code, freed from the underlying infrastructure. Finally, SaaS, software as a service, delivers ready-to-use software online. You simply log in and start working, with no installation or maintenance needed. It lets businesses choose their precise level of control and convenience. Let me walk you through the big differences between cloud and on-premises infrastructure. Think of the cloud as a flexible, pay-as-you-go service where you only use and pay for what you need, with elastic scaling on demand. Service providers manage everything, making rapid deployment easy. On the flip side, on-premises requires a capital-intensive upfront investment to build and maintain your own setup. You get complete control, but it means fixed capacity and physical maintenance. Increasingly, businesses are adopting a hybrid approach, combining the best of both worlds to get flexibility, control, and optimized performance for diverse workload requirements. Let me walk you through the idea of hybrid infrastructure. Basically, it's all about intelligently blending your own private data centers, which are on-premises, with public cloud services. Think of it like keeping your most sensitive data and regulated workloads secure in your private vault at home. while also leveraging the public cloud's massive, scalable resources for dynamic applications that need to grow quickly. This powerful approach lets you truly optimize workloads, giving you maximum control where it matters most, alongside incredible flexibility and global reach for everything else. Time to understand the critical concept of shared responsibility in the cloud. Think of it like a hotel. The cloud provider secures the building itself, the physical infrastructure, data centers, and underlying network. But you, the customer, are responsible for securing what's inside your room, your application code, data, and how you configure your operating systems and access controls. That's why 99% of cloud breaches stem from customer-side misconfigurations. Thankfully, advanced AI-driven innovation now helps us proactively predict threats and detect anomalies, acting like smart, vigilant security for our room in the cloud. Let's unpack the financial shift in cloud adoption. It's really about transforming capital expenditures, CapEx, into operational expenses, OpEx, meaning organizations pay only for resources actually used, eliminating massive upfront investments. However, we must watch for hidden costs, like data egress fees when transferring data, or unknowingly over-provisioning unused resources that continue accruing charges. Thankfully, AI-powered optimization tools are now dynamically adjusting resource allocation, automatically scaling down during low-demand periods to minimize unnecessary spending. Ultimately, strategic hybrid models help balance costs, optimizing total cost of ownership by blending cloud and on-premises workloads effectively. Let me walk you through the incredible shift we see with cloud transformation. Before, companies often grappled with large upfront hardware purchases and frustrating, weeks-long provisioning cycles, facing limited scalability and physical space constraints. Now, after cloud adoption, it's a complete game changer. You get instant resource provisioning, unlimited elastic scaling, and global reach for your services. This allows for continuous innovation cycles, and often leads to a significant 30 to 50% cost reduction, all while dramatically improving agility and security. It's like moving from building your own power plant to simply plugging into an infinite energy grid. Let's get into some fascinating trends shaping cloud and infrastructure. We're seeing AI-driven operations really take center stage, with AI automating everything from resource scaling to real-time threat detection, adapting intelligently to changing conditions. Alongside this, edge-to-cloud integration is enabling ultra-low latency data processing right where the action is, like for smart IoT devices. Plus, serverless computing continues its rapid adoption, eliminating infrastructure management entirely for faster, more cost-efficient applications. And importantly, there's a massive push for sustainability, driving providers to build energy-efficient data centers powered by renewable sources. It's about building smarter, greener, and more responsive cloud environments. Let me introduce you to why cloud computing is truly foundational for modern business agility and innovation. It's no longer optional. To truly leverage it, mastering key concepts like service models, IaaS, PaaS, SaaS, hybrid strategies, security, and costs is essential. Also, embrace emerging technologies like AI tools to optimize your infrastructure. Begin your cloud transformation journey strategically. Thank you for your engagement today. I hope this information serves you well, and thank you for participating. Hello learners. It's wonderful to see you here. We're going to discover the exciting world of server infrastructure, specifically how to build a truly successful career with an IT infrastructure. Think of it like a comprehensive skills roadmap. We'll explore the various career paths available, guiding you from entry-level roles all the way up to impactful leadership positions. It's about understanding what skills you need, when you need them, and how to navigate your professional journey effectively. We'll make your path crystal clear. Let's unpack these entry-level infrastructure roles, which are truly your foundational stepping stones into the IT world. Think of them as your training ground. Whether you're a system administrator managing servers and user accounts, a network technician configuring vital network connections, or an IT support specialist troubleshooting daily hardware and software issues, you're gaining crucial hands-on experience. These roles are invaluable for building that critical knowledge base, letting you see how all the pieces fit together in complex enterprise environments. It's how you truly understand infrastructure and prepare to advance your career. Let me guide you through the essential toolkit for any successful infrastructure professional. First, you absolutely need operating systems mastery. That's deep proficiency with Windows Server environments and various Linux distributions like Ubuntu. Then solid networking fundamentals are non-negotiable, understanding things like TCP/IP protocols and firewall management, which are the very backbone. Automation via scripting with PowerShell or Python is crucial to boost efficiency. And finally, the ability to troubleshoot complex issues quickly during critical outages is what truly sets you apart and keeps everything running smoothly. Let's explore the concept of professional certifications and how they truly open doors in your career. Think of them as valuable badges that validate your skills. For instance, vendor-neutral credentials like CompTIA A Network Plus show you understand fundamental networking, while a Cisco CCNA is essential for infrastructure design. Then you have specialized ones like Microsoft Azure or AWS certifications, which prove your cloud platform expertise. These aren't just paper, they're recognized industry-wide, proving you have the practical knowledge employers are looking for, highly recommended for career advancement. Let me guide you through how these crucial tech roles keep our digital world running smoothly. An infrastructure engineer is like the architect of a city's utilities, ensuring 99.9% uptime and scalability of IT systems through proactive monitoring and smart planning. Think of them managing secure patient data, implementing disaster recovery. Then, a DevOps specialist blends this infrastructure knowledge with automation, using CI/CD pipelines for continuous deployment. Finally, a platform engineer designs and maintains the cloud-native infrastructure for modern applications, leveraging powerful tools like Kubernetes and microservices. What we're looking at here is a fascinating career progression within IT infrastructure, truly evolving from the ground up. You typically start with hands-on troubleshooting, really learning the systems and building that crucial technical foundation. But as you progress, your role shifts dramatically. You move past just fixing problems to designing solutions, leading complex initiatives, and even mentoring junior staff. Ultimately, you're making big architecture decisions, owning budgets, and influencing company-wide IT strategy, shaping the entire organization's digital capabilities. It's a clear journey from tactical tasks to strategic leadership. Let's consider how we truly build our technical skill set. It's not enough to just read about new tech. You need continuous learning combined with practical experience. Think of it like a musician practicing scales and performing. We can set up home labs or leverage cloud sandboxes to practice real-world configurations, getting hands-on. Also, contributing to open-source projects, like writing automation scripts for tools such as Ansible, is invaluable. And of course, staying current with emerging technologies like Kubernetes or serverless architectures keeps us sharp. This blend truly fosters deep understanding. Let me walk you through what comes next after you've really mastered the fundamentals. It's all about specializing your expertise and really going deep in a specific area. Think of it like this. Instead of being a generalist, you become the go-to expert. You might dive into cloud infrastructure with AWS or Azure, or perhaps secure infrastructure design and cybersecurity. Automation, through things like DevOps and CI/CD, is another incredibly valuable path, as is network architecture. Alongside this specialization, pursue advanced certifications that align with your chosen field, like an AWS Solutions Architect credential. And crucially, don't forget professional networking. Joining industry groups and attending conferences makes a huge difference. Let's explore the concept of fast-tracking your infrastructure career. It often begins with foundational hands-on experience, perhaps mastering troubleshooting and help desk support. The real magic happens with continuous learning, though. Think about earning certifications like Network Plus and Security Plus, and crucially developing skills like PowerShell scripting. When you apply that knowledge to automation projects, even gaining cloud experience, you can rapidly transition from entry-level to an infrastructure engineer role. It's this blend of practical application and strategic skill development that truly accelerates your journey. Let's discover how to truly excel in an infrastructure career. It all starts with building strong foundations, like getting hands-on experience and pursuing relevant certifications to validate your growing expertise. Remember, this world is constantly evolving. Think cloud platforms and containerization, so embracing continuous learning is key to staying adaptable. Always seek growth opportunities that challenge you, expanding your impact as you help power the digital backbone of tomorrow. I appreciate your dedication to learning. I hope this was enlightening and thank you for being here.